Hello and welcome to my video on functions of polar coordinates. Don't forget, this is after you learn how to actually graph a function. Now, we're going to, or how you learn what polar coordinates are. For a polar coordinate, r is often a function of sine or of theta. So if I had r equals sine theta, I don't know why I wrote that on the paper. Let's actually just graph that. Sine, r equals theta. If I take that out just to 2 pi, you can see as my angle of rotation increases, my distance away from 0 increases. What's interesting about that is that, I'm going to change this to a, and I'm just going to let a go in between 0 and 2 pi. You can see as my angle increases, my radius increases. And I like this animation because you can actually see that happening. Now, if I wanted to, I could sit here and I could set up an in and out table. I could use my table of relevant trig values, right? We're really going to like, by the way, 90, 180, 270, 360, 0, 0, right? We really like 90-degree angles. They're easier to remember and they pop up quite nicely when we are trying to graph. Now, let's briefly think about what a graph of sine would look like. Well, let's just make an in and out table. If you make an in and out table, you can kind of graph whatever you want. All right, so theta r 0. And please do keep that table handy that I showed earlier. You likely already have a handout for it. Let me just zoom in a little bit on my graph. And the table that I'm talking about is this thing right here. Now, theta r, and this is r equals sine theta. At 0, sine is 0. At pi over 2, sine is 1. So right away I know that I have these 2 points. Whoop, not you. That was the wrong one. 0, 0. Theta r equals sine theta. I can do this. I will not lose my mind. I've already lost one recording today. Pi over 2, 1. So right away I know that I've got these 2 points, right? At pi, I'm at 0. 3 pi over 2. So once again, I'm back on the origin. Whatever your distance away from the origin is 0, the point 0 is on there. 3 pi over 2, I'm at -1. So when my angle is, all the way around here, my distance is not 1, but -1, which perpetuates this point here. I'm just going to erase this meow. If I want to, I could sit here and I could be like, oh, well, sine of pi over 4 and, 3 pi over 4 and all those, and I could graph this out. Right? Pi over 4 is like here. Pi over 4, it's root 2 over 2. It's something right around there-ish. But ultimately, if I want to, I could make an in and out table. I could graph this bad Larry. Let's clear all, and let's actually look at an example of what this graph will look like. Clear all that. And here we've got a circle. And keep in mind, right, pi over 2 is like 1.5, right? So as I get closer to 1.5 for what I'm graphing up to, I'm reaching that half point on the circle. As I get past it, I'm coming back. As I go forward, right, 3 pi over 2 is going to be, I don't know, 4.5-ish. Right? We can't see that because, again, we're just bouncing back. Now, why is this useful to know? Well, not everything's quite so simple as sine. Here I've got r equals 4 sine of 2 cosine of 2 pi. So this thing is redonkulous. But we get this pretty clover shape. And keep in mind, as I move a back and forth, I'm just whipping around, right? Whipping around within my degrees. Now, if I want to, I could sit here and I could plug in pi over 2, 2 pi, all that stuff. But I'm not going to get a whole lot out of that. For this one, why you need to know about polar graphs, because we might have questions like this. Which is a graph of the function r equals 1 minus 2 cosine of theta? Please pause the video and check out these graphs. Let me move in. Can I move in a little bit without effing everything up a little? Oh, yeah. All right, this is an original question based off of one that I found online that I liked. But I'm just going to start with, making an in and out table, seeing which one works. So I'm going to plug in 0 to my equation. So off to the side, I'm going to do 1 minus 2 cosine of 0. I'm going to use my table, figure out what is cosine of 0. Cosine of 0 is 1. Oh, you went away, you beasting. R equals 1 minus 2 times 1 equals negative 1. So right away, I know that 0, negative 1 on my in and out table should be on the graph. Where is 0, negative 1? Well, at 0 angle of rotation, my distance away from the origin should be negative 1. Now I can't be out here. I got to be at that green point. I can cross you out. Ooh, I like that. And I can cross you out because you don't have that point. Now, what's easier than 0 degrees? Or what's also easier relative to 0 degrees? Let's do pi over 2 because that's 90 degrees. All right, so I need cosine of pi over 2, which is 0. Ooh, where are you? There we are. Oh, thank you. Let me just remake that all. We crossed out you and you. And we got pi over 2, comma, 1 minus 2 times 0 is 1. So I need that point and I need that point. All right, so they're both good. Let's go to pi. So 1 minus 2 times cosine of pi. Cosine of pi, I'm not going to go to the other tab because I'm going to lose all this. I'm going to lose my mind. Cosine of pi is negative 1. So this is going to become 1 minus 2 times negative 1, which is 3. So at pi, I need to be 3 units away from the origin, which is that point there on this graph. So I don't like him. I am going to choose A. But the point here is that if I can just make an in and out table, I can get these problems done. What else might an AP question look like? Well, I was Googling that, and I found this. This is I just got this from Googling. I Googled AP Pre-Calculus Polar Graphs Multiple Choice Questions, College Board. So no private access. Let's go back down. There we are. Please take a second, pause the video, and read. I'll stop moving. Read this question. Okay. You pause the video, you're great. The video shows a graph, the polar function, blah, blah, blah. There are 5 points labeled. A, B, C, D, E. If the domain is restricted to 0 to pi over 2, the portion of the graph given that remains consists of 2 pieces. One of those pieces is the portion of the graph in quadrant 1. Quadrant 1 is this. From C to E. So that's that chunk. I'm going to leave that there. Which of the following other pieces remain? So, I'm only graphed from there to there. It's a pretty safe bet to say that they only gave me half of that, right? Because they told us that we've got 2 pieces. They gave us 1. There's so much symmetry in trigonometry that we need to be careful. Meow. What am I going to do? I'm going to assume that they gave us that first chunk. I'm going to plug in pi over 2 to this equation. Pi over 2 I'm choosing because that's that latter half. So let's see. 4 cosine of 2 times pi over 2. Those cross out. I'm looking at 4 cosine of pi. 4 cosine of pi. Let's see. Cosine of pi I know from earlier is -1. So at pi over 2, -1 at -4 should be on the graph. So I'm just going to jot that down. Pi over 2, which is 9 degrees, -4 is on the graph. So on my graph, I'm going to go up here. That's pi over 2, right? That's 90 degrees. And I need to be -4. So the point D must be on my graph. So I need to go from, there's no way to go from C to D. So I must go from E to D, which makes my answer D. All right, so I'm just going to assume, the point D must be on the graph because that is the point pi over 2 comma -4. But again, all this from just being like, hey, I've got some information. If this didn't work, I would choose 0, just the other end of the spectrum.